So Module 4 is going to deal with the scientific revolution and the Enlightenment. And we're really going to run all the way from about the 15th century to the 18th century. So we're talking about the 1400s, late 1400s to the 1700s, okay? But we're going to primarily focus on the 16th and 17th century. But obviously there are some scientists that are going to extend back quite a bit, so we do have to extend those dates out a little further. Basically at the time, you have a lot of Europeans that are looking at the natural world, and they are trying to understand and create a new way of looking at the world. They don't want to accept the old polytheistic of like there's just one God that does everything, the old Germanic, the old ancient Near East, basically the Roman, all of these things, the emergence of Christianity, the emergence of there's one God actually did more, if you really want to look at it in a really critical way, the idea that all of culture said that there's not multiple gods that control all of these natural forces. The emergence of monotheism actually did more to create a larger reliance on science, which then, of course, led to the rejection of a deity to begin with, which is kind of an interesting way to think about it, because if I can't just say, hey, the sun god Ra pulls the sun across the sky anymore, I actually have to come up with a way and a reason scientifically that this happens. Then, because of, I know there's only one God, now I have to start looking at it and going, well, can science explain the things that we think God explains? So it's kind of an interesting kind of series of events that actually kind of leads to a lot of what we are going to end up talking about and saying deism, which is kind of the rejection of a, loving, caring God, single God that actually controls the universe, but maybe, and they shift more towards the idea that there was a God and a creator, he started the whole thing and then just lets it spin, right? And that never happened before until monotheism created the need to actually understand it scientifically. So I think it's a really interesting kind of time frame to look at and how this all kind of emerges. There's going to be some long-term consequences, obviously, as we just said. And for the first time, I think that you have both a culture emerging in Europe and the empirical observations that are going to kind of bring an understanding of how that culture actually works and how people actually work. And they're going to start calling to find out about natural laws and how those are going to lead to a vast amount of scientific achievement. And so basically they had, up to this point, Europeans during the Middle Ages had been really lost in the dark. And then they get back and they get the writings of Aristotle and they get some of the Greeks and they get some of these ancient writings. And so they're going, hey, maybe they were onto some stuff, but how can we actually improve it with our new understanding of monotheism? And believe it or not, a lot of what Aristotle and some of those very early Greek philosophers and scientists did, I think, had some validity to it. They had some understanding far beyond what they should have, but they developed this far beyond that. So, obviously, they start realizing hey, if the Earth is the center of the solar system, some of this math that we have figured out is not going to work right. This doesn't work if the math is that we're at the center and everything revolves around us. Some of this stuff doesn't make sense. So we're going to look at how that kind of emerges. So we're going to continue here. There's a few things that we need to understand. Number one, the stakes are incredibly high, not just because they need to figure things out, but it's not just science being at stake or the understanding of the world or how it works or the laws or the physical properties or anything like that, because we know that we're going to eventually get gravity and thermodynamics and all of these things are going to come along later with all of this. But we're also going to understand, the Earth and astronomy, and these are going to lead to important questions, and that, the past sciences just don't have the ability to answer. Like what constitutes knowledge? How do we know? and what do we know, and why do we need to know, and because, you get educated and you experience things, and all of a sudden you start to ask real questions with a new viewpoint. And so some of these things are going to go far beyond science. As wonderful as science is, you have to understand that these go beyond that. Now, before the 15th and 16th century, the dominant idea was that the earth is made up of 4 elements. And I believe we talked about this in our first semester. And they believed that the 4 elements were earth, water, air, and fire. And that's really an old Greek idea because of their very limited understanding, and nobody had really improved much on that during this time frame. But with some new improvements in technology, primarily say like the telescope, now we can start to look at the stars and look at other planets, and we can see their movements, and we can realize, wait a minute, if the Earth is at the center of this, like I said, the math doesn't work right. Why is that planet not in the same spot every time during every season? If everything's revolving around us, why do the planets not end up in the same spot all the time, right? That doesn't make any sense. Because if everything was making one revolution around us a year, then that planet and that star should be right there every single year, no matter what. But it's not. And so they go, we need to start looking at this, right? They're going to start questioning all these ideas that had been taken for granted by like people like Aristotle. And then you end up with like Newton, and Newton's going to learn from his contemporaries, and that the world is made, or the universe does not revolve around the Earth, but the Earth is actually moving through space, and he's able to prove this, not just with supposition, not with just thinking it's true, but he's able to actually prove it. And so we're going to have an entire shift in the human mind into these more data-driven ideas that go along with the scientific revolution. And it's not going to be an easy transition because it's actually going to get very messy trying to figure all this out, and very challenging because it's really going to stand in the face of some of the existing power structures, right? When you start to think like this, because the Catholic Church, they go, God created us, he must have put us at the center. And when somebody comes along and goes, actually, guys, we're not the center of the universe, the Catholic Church is going to go, yes, we are. God made us special. We have to be the center. Why would he not put us at the center? That doesn't make any sense, right? So that's going to be a big part of this. Now, to be fair, during this time, they are basically rejecting some of these bold ideas. But the movement itself still has some, causes and roots in medieval intellectual life and in those medieval university systems, especially their emphasis on mathematics. If you'll remember, in the late Middle Ages, you have things like humanism showing up, and these humanist scholars are getting increasingly dissatisfied with the ancient authors because of their lack of adequate data. You had these thinkers who were just going, well, this makes sense. I've thought about it a whole lot, so I think that this is how it is. And people like Galileo are going, yeah, but did you track anything, or is this just because you thought about it for a long time and it just made sense? I can think of a lot of things that just make sense, but it doesn't mean they're true, just because I can justify them in my brain. And so those medieval scholars, like I said, and remember, where were the medieval scholars trained? Remember, it was cathedral universities. These were universities basically taught by the church. And so obviously those are also going to be leaning towards church theology. And so when these medieval scholars become humanist Renaissance thinkers, their writings are going to transform and eventually inspire the leaders of the scientific revolution. You're also going to have the translation of a lot of these classical works, and people are going to start to ask fundamental and legitimate questions and analytical questions that, hey, is this fake news? Is this something, that is just our wisdom tells us, or whatever, right? Same thing we saw happen with like the Protestant Reformation with the church. They start reading it for themselves. All of a sudden, they actually start to go, wait a minute, I don't think that that's what that says. Well, once these people start looking at the old way of thinking about the universe, they start looking at the data and they go, well, I don't think that that's what this data actually says. So there's really a close connection between that. The first major discovery in this revolution does have to do with astronomy. The telescope, as I said, this is going to advance theories about what they see in the heavens. They're going to use what we would call inductive reasoning, and they're going to start with disparities, like these different facts, and work towards a theory to bring them all together. And this is what's called inductive reasoning, which is the opposite of deductive reasoning, where you start with a known theory and you try and fit the observations into it, right? And both of them are very important for science. And, the classic example of the deductive, was the idea that the Earth was the center of the universe, and then trying to force the movement of the stars into that theory. Now we're looking at the movement of the stars and saying, well, all of this adds up to something else, so inductively I can reason that what we have thought is wrong. Okay? So it's the difference between working from the middle out and from the out to the middle. And both of them, like I said, are important, but what we're going to see is that while they're both valuable, they're not going to fit together very well when your deductive reasoning and your inductive reasoning are coming to different conclusions. To prove something's correct, you should be able to go from a deductive standpoint, start with your theory of gravity and say, hey, here's my theory of gravity. All the things that I can do confirm that. Or I can do a bunch of tests and come to the realization that gravity exists. And I'm going to get the same conclusion, 9.8 meters per second squared, pull towards the Earth, going outwards or inwards on that. Now that's real. So the idea here is that we're trying to combine inductive and deductive to get the same result, because that means that it's actually true. The first guy that in particular that we want to talk about is actually a guy named Copernicus. And believe it or not, Copernicus wanted to glorify God through his understanding of science and his place in it. His major claim to fame is coming up with the idea that the sun was actually the center of the universe, or what we call the heliocentric universe model. And this challenges the old idea. And remember, the old ideas are really linked to major power structures like kings and the Catholic Church, and it's very upsetting to them. And they actually claim that to say the sun is the center of the universe and not the earth was heresy. They believed that it was anti-God to say that we were not the center of the universe. And we obviously know today, well, he's right. But it was a very controversial thing in his day. And something that some of his fellow scientists really tried to disprove that, hey, the Earth is the center. Well, Copernicus is going to invest a huge amount of resources. He has kings giving him money to build his observatory. That way he can look at the sun and the stars and try and disprove, what's going on. He also challenges the idea of circular orbits, that the orbit is just in one big circle. He says those don't make sense. What he discovers is that they're actually not in perfect circles, right? They're elliptical. And so he writes about this and all of these things about the evolution of the heavenly spheres. And, he really sparks a lot of interesting debate. And his theories aren't, exactly perfect. Right? He doesn't have a perfect understanding, but the fact that he has completely shifted the idea is really going to lead others to try and say, hey, I think that he's right. Now, he may be wrong a little bit about this or about this, and we can clear that up as we go and get more technology and more understanding. But clearly, his model is correct that the Earth's not at the center of this. So he really is a really important guy. Then we're going to talk about Johannes Kepler. Kepler will basically advance these theories of Copernicus and do a pretty marvelous job of actually proving them mathematically. And he really goes and Kepler actually started as the understudy of the main guy who's trying to argue against Copernicus. This guy who's trying to say, no, Copernicus is wrong. Kepler actually starts working for him, and they work really, 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 really hard to try and prove Copernicus wrong. And when they can't, Kepler goes, well, we've done everything we can to prove Copernicus wrong, and everything we do keeps proving him right. I'm changing sides. The whole idea of if you can't beat him, join him, right? Clearly, we're wrong and he's right. So we're going to roll with that. And so Kepler, he begins to work at this observatory. It allows him to make all types of theories and ideas about the formation of the stars and the planets. He takes his turn into, the dynamic workings of a sun-centered system. And he shows that all sorts of things that change, like the planets don't move at uniform speeds, right? That all planets are not moving in the same exact speed or same exact motion, right? 1 year on Earth is not 1 year on Mars, and it doesn't take the same amount of time for Mars to go around the sun as it does for Earth to go around the sun, which a lot of people thought it did. And, he's able to figure these out through observation. He's not able to prove why or be exact, but he is able to figure out that, hey, Copernicus is kind of wrong. But some of the math that he comes up to actually really does lay the groundwork for people that come after him as well, like Newton. And so, he kind of bridges that gap between Copernicus and some of the later people. And shows the accurate theory about the sun and the planets. And then you have guys that we're going to talk about next, like Galileo, who is actually going to come along and really, put pen to paper and prove, kind of without a shadow of a doubt, all of these things that were still kind of, we have some data, but not enough to really prove it. And until you have the invention of like calculus and some of these other more advanced mathematics that weren't really around yet, mathematically, we can't really prove what they're seeing. They just know what they're seeing. But Galileo and then Newton and some of these guys later on, they're actually going to be like, hey, this is the model and this is the math that proves it. So these are foundational guys to the scientific revolution. And that brings us to Galileo Galilei, which is a fun name to say, Galileo Galilei. He is definitely the most significant scholar working on heliocentrism. And Galileo builds a telescope, which allowed him to make his own observations. And he comes up with a mathematical formula to account for the observations. And he's kind of delighted to sort of publicly demonstrate all of this. And he's the one who's really more famous and read more than all the others. In his first major publication, The Starry Messenger, which he writes in 1610, he conclusively demonstrated that the heavens contained previously unknown objects, such as moons of Jupiter, and in the same manner that Earth has the moon, that there are other planets that have moons. So not only do we all revolve around the sun, but other things revolve around us, right? As we revolve around the sun. And it's not just Earth, that this happens with other planets as well. And it's kind of going against the old idea of, static, perfect heavens and universe. Then in 1632, he publishes his more important work, The Dialogue. And the use of that work, he takes early astronomers and his own observations to support the formation of the universe, and again becomes much better known right away than any of Kepler's works. Now, the dialogue is an old Greek idea where you put two views in opposition to each other by basically he has two characters in his book. And one of the characters is arguing for the old way of looking at things, and he basically uses this character's dialogue to, present the evidence. And then he takes another character that presents his evidence, and he basically says, here's all the evidence. And he allows the reader to read both sides, kind of in an argument style. And the ultimate result is you look at all the evidence and you go, oh, yeah, Galileo's right. Clearly, there's way more evidence that actually proves what he's saying. And so, basically, it's funny because, he's got this guy, and then the debate partner is named Simplicio, Simplicio, which is funny because he's got his character that's arguing for heliocentrism, and the other character is Simplicio, which in Italian means stupid. So he's literally saying, here's a book about two people that are debating, the person who's right and a stupid person. Who are you going to believe? My guy or the man named Stupid? And so and obviously stupid is going to lose every argument. And you can attach stupidity to the Earth-centric model and all of this, and it's pretty interesting. People don't like that. Not only is he saying that they're wrong, like the Pope and the church and the kings, not only is he saying they're wrong, but he's saying if you believe in this, you're stupid. He's calling the Pope stupid to his face. Okay? They don't like that. So he ends up basically being put on trial eventually by the Inquisition. They find him guilty. And Pope, I believe it was Urban VIII, he doesn't like that. Galileo is accused of supporting a condemned doctrine of heliocentrism. Says you're a heretic, and they force him to recant. They actually force him to be like, oh, guys, I'm wrong, even though all the evidence says I'm right. And they put his book on the Catholic Index of Banned Books. The Catholic Church basically says, if you read this, you're going to hell. If you read that the earth is not the center of the universe, you're going to hell. Guys, it stayed on there. So this was back, 1600? The Catholic Church leaves the dialogue on its list of banned books until 1822. Okay? He was never beaten or tortured or executed. He was just excommunicated, but, it's still, he's working. They tell him, hey, quit talking like this. You're going to be on house arrest, basically. Nobody should deal with you. He's like, fine, that's cool. And so he goes to his house and he makes a telescope to work from his home, and he continues to work and publishes another work called The Two Sciences of Motion and Mechanics. It provides a theory and mathematical formula for immersion and some of the ideas of gravity that people end up finishing and detailing for us. And he claims that objects are going to stay in motion and that there's direct evidence of that. And, it's pretty funny that he just says, I know that y'all think I'm a heretic, but science can't be muzzled. And I'm not going to let the Catholic Church muzzle me. And we're going to just keep talking about this, which is hilarious. He's very much a rebel, and it cost him really everything, depending on how much you believe that the Pope can keep you out of heaven. The Pope basically said you don't get in, Galileo. Now, again, it seemed like a silly thing for the Pope to be able to keep Galileo out of heaven about, but I guess he could have, I don't really know. If the Pope is infallible, maybe the earth was the center of the universe. I don't know. And then when the Pope finally said, maybe it is the sun, then all of a sudden it swapped. I don't know the theology on that. And I'm not trying to be critical of anybody. I'm simply saying the Pope was wrong. He was wrong. And we have talked about throughout this class how sometimes the Pope knew they were wrong and they did it anyways because they were in charge and they could. The Catholic Church has been reformed quite a bit, so don't worry, everybody. I'm not talking about today. I'm just saying back then. Now, that will bring us to Francis Bacon, who gets enormous credit for being the father of the scientific revolution and the scientific method, but also the founder of the deductive method, which I mentioned earlier. And Bacon is really, there's a couple great slogans that he kind of comes up with, I don't know. He has a lot of like really important sayings that come out of his writings. Embrace writing, learn to appreciate what it does for your mind, stuff like that. He was a lawyer, a statesman, a philosopher. In addition to being a scientist, he was kind of the Leonardo da Vinci of his time. I guess you could kind of put it that way. Leonardo da Vinci kind of did everything. Francis Bacon kind of did everything as well. He was working to give, quote, the true directions concerning the interpretation of nature and, from being, to being a primary science, that nature is primary. And he feels like this is a very important contribution. He's laying out these steps about how we should go observing nature. And this is eventually going to culminate in what we said was the scientific method, which you probably learned all the way back like in elementary school, right? Oh, we're going to do an experiment. We have to come up with a hypothesis, and then we have to build our experiment, and then we test it, and then we look at the conclusions, and then we retest, right? And so thanks, Francis Bacon, for all of that. He is a figure for the next generation of people, and we're going to talk about, inductive reasoning and all of that stuff, but here's what he kind of recognized. He recognized many scientists or thinkers during his day give inadequate treatment of these important complex topics like nature and the universe because they're making deductions based on a theory that they uncritically accept. So if you are uncritically accepting something, if you would just accept something because you were told it's true, then you are setting yourself up to make all of your observations based on a lie. Instead, you should critically test all of that. And, that will help us better avoid, generalizations and stuff like that. And so you should build these data and all these things to build a case that allows you to build a strong theory. And it's going to allow you to eliminate defective theories. And ultimately, again, he calls it inductive reasoning. He's very, very keen on practical and useful knowledge. And that's why he was a very influential thinker. And so don't forget about Francis Bacon there. Now, yes? The next thing we're going to look at is Rene Descartes and his idea of deductive reasoning. Rene Descartes, his idea of critical thinking is doubting. So he believes that, there is significant value in doubt and using logic and critiquing and asking, can you be sure of a philosophical standpoint? And what the conclusion is that if you doubt it and then you test it, then you can prove that it's true. But if you just accept it, you can't prove anything is true because you've already accepted the conclusion. So you should doubt it. His very famous quote there, I think, therefore I am, right? Because I can think about it, I can prove that I am something. You're basically the idea that being a thinker allows you to prove what you believe and thinking about it, not just claiming it. He goes along and follows logical proofs, and he starts beginning to try and, take that to religion, which gets him in trouble, starting to say, hey, how do we critically think about the existence of God and some of these things? And that's kind of, a difficult thing, but he is also kind of the father of analytical geometry, again, like geometric proofs. Not geographic, that's different. He personally embraces that God was benevolent and reasonable and the power behind creation, but that he did not meddle in the universe. And, he's basically saying that God created everything, he put it in motion, but he's not actively, messing around with gravity. He's not, changing the dial on us every now and then just to see what happens, you know what I mean? Like there's some people that get on the scale and they wish, after Thanksgiving and Christmas, and they get to January and they're like, oh, how much do I weigh now? And they're like, that silly creator of the universe dialing up gravity again, making me weigh more. No, that's not happening, right? Like that's, we can prove that gravity's always the same. You just ate too much, bro. And so he's going to, really go in that direction. Let's see. Really important. Rene Descartes was a really, really important kind of thinker there. Then we're going to get kind of to the peak of the scientific revolution, and one of the most influential thinkers and scientists of them all, Sir Isaac Newton. And I think he's definitely the most important figure. He's an English mathematician initially, becomes, of course, famous scientist as well. Simply put, he was a genius. He was the chair professor of mathematics at Cambridge University, he was, on the board of many prestigious universities, and all the world today still uses what he did and what he came up with, and he came up with all of that at the tender age of 27. He's 27 when the apple supposedly falls and hits him on the head, right? And he thinks about gravity. He's renowned within his own lifetime for being a great mind. A lot of these other guys, they were famous, but they don't get credit until much later on, when Newton's theories actually and his math actually go on to prove what most of them did. Then people look back at them and go, oh, we probably mistreated Galileo, right? Newton, instantly, people were like, oh, this dude's on a whole nother level. Like, this dude's smart. He published the Principia, which is about mathematical principles of the natural world, or natural philosophy. He proposed a single universal gravity that applied equally to enormous objects like the Earth and minute tiny objects as well, and everything in between. And he said there's an entire system of physics, and he maps out and describes in precise and accurate mathematical formulas. He's essentially one of the great single works of science of all time. It's not just because he was right, because he was definitely right, but it's also because he provides a comprehensive system that can replace those authors like Aristotle and people before him. And so he is increasingly regarded as the most important thinker and individual throughout history and during the history of ideas. But in terms of scientific accuracy, he's also right there as well. He proves the forces of gravity and other laws like the laws of motion, which are really fundamental principles of understanding the universe. By doing this, he does, he uses inductive and deductive reasoning. He recognizes if I pick one or the other, I'm going to get less useful theories. But if I use them both, then I'm going to be able to really narrow down on what is real. He says the universe is governed by natural laws. He's also a devout Christian. So again, he is definitely very influential. Now, he's also into some really kind of weird things like alchemy. He's an alchemist, which he believes like that chemistry, you can use chemistry and metals to find immortality, and if you understand the right properties of metals, that like you can turn stuff into gold and change like other metals into gold. And he had some weird stuff because they didn't have like as much of an understanding of the atom and some of those things, but his math was spot on, right? And so really strong principles of physics and astronomy. But chemistry and biology still got a long way to go when it comes to that. Nonetheless, Newton's legacy is sterling, right? He's very prestigious. There we go. Now we're going to talk about women in the scientific revolution. Unfortunately, there's some good news and bad news. We're going to go, with the good news first, I guess. I don't know. And then the unfortunate things. First, noble women do collaborate with their husbands, and they were sort of co-workers that helped them with their theories and check the details and so on. People like Maria Sibylla Marian, who's an entomologist. She goes on trips to South Africa to study insects and draws very detailed things But she's really doesn't get a whole lot of credit because it all goes to her husband. They also make very important medical discoveries, such as how to treat malaria, which is going to benefit mankind greatly. But she's obviously not the first female scientist, but she's one of the first ones that is famous. And despite all of this, the fact that there's lots of highly qualified, educated women scientists, informal rules ban them from actually joining scientific societies or holding university positions, which is totally just biased against them. But it's safe to say that I think that one of the great failings of the scientific revolution is the inability to overcome the prejudices in the treatment of women. Now, scientific communities now, that's not the case, and despite all this new science, we're still working on trying to overthrow these very sexist stereotypes, and it's very unfortunate, but worse still is that you end up with these people who study anatomy, and they start to intentionally show women different than men. Women have wider hips, and that means that they're destined for childbirth, and that's their primary function. So they should, we should educate them to a certain point, and then once they can start having kids, we shouldn't deny God's plan for them to have children, right? And so that's going to kind of delve into the pseudosciences and their claims about women and the anatomy and their skulls and all these things. It's really just to keep them in their place from being recognized in scientific terms, and that's very sad. Coming up on the end here, imagine the consequences of this whole thing. They're pretty much all over the place. When it comes to women, the consequences are negative. When it comes to the advancements of scientific understanding, it's pretty amazing, right? So it's a mixed bag, of course, during this time frame. We had the rise of scientific communities, scientific method, the understanding of the universe, the governing of natural laws that are predictable and repeatable, and it all leads to a big question. What laws should be about? A scientist says, hey, these laws govern the motion of planetary bodies. They're laws that govern the life on Earth, like gravity. And they have social consequences, political consequences. But should there be laws that govern us, right? Like the idea of the divine right of kings and absolutists. What do we make of God? What is God? Who is God? Is there still a place for God in human affairs? Which is a very difficult thing for a lot of religious people. And what you end up with is this mix and falling out somewhat between faith and science that continues to the present. So again, it's kind of like we said at the very beginning. It's kind of interesting how these advancements in the name of monotheism end up creating the questions about that deity to begin with. And so it's really a kind of a strange thing. And that's going to lead us to human reasoning, and it'll sort of become a very mechanical view of the universe. It kind of demystifies and despiritualizes and disenchants kind of what the universe is. And again, it's kind of sad because the understanding of gravity and the understanding of all these things, you understand that all of these things happen naturally in the universe. So did somebody just plug up the universe and just let it be like a machine that just kind of chugs along and plugs along and goes, and the pistons keep firing like the engines of your car? But does that mean that we can't appreciate them and marvel in the beauty of it? And so it leads to a very deistic view of God. People like our founding fathers use deism, and people like Thomas Jefferson felt like the earth and the universe was kind of like a clock that God kind of wound up and just let go. In fact, Jefferson had somebody actually, because he was such a deist, he didn't believe that God was intervening at all. But he wanted to believe in, a God. He believed in a God. So he actually had somebody take a version of the Bible and rewrite it without all the miracles in it. Because he said, well, miracles can't happen because God doesn't intervene in human things. God doesn't change the rules just because he wants to. If somebody's sick, he's not just going to heal them just because. So he actually had a copy of the Bible written that took all the miracles out. Oh, I believe in God, just not that he's willing to do anything. That he can do anything he wants whenever he wants. And so, it's really, you end up with this very strange relationship between the scientific evolutions and the impacts on religion and society and culture. And so Newton and all these other guys, many of them were Christians and they believed and were working from a Christian faith. but then the people who learn from them don't always take that same viewpoint. And I think that that's a very interesting thing to take note of.